Let us read through this programming project. Project 1, Sudoku solution validator. This is your lab 4 exercise. Okay, for this problem, you are given a grid of 9 times 9 grid. So there are many versions of Sudoku. So this one is 9 by 9 grid. So in order to validate the Sudoku, what is the definition of valid Sudoku? So the number here, it must be between 1 to 9, because the size is 9 by 9. So the minimum number is 1 and the maximum number is 9. For example, here this is the first row, second row, third row, and you should have 9 row and 9 column. So for the first row, we can say that the first row is a valid solution if all number from 1 to 9 exist in this row, in the first row, in no particular order, as long as you have all the number from 1 to 9 in that row. Similarly, in the second row, you have the all the nine number. So you can say that the first row is valid. The second row is also valid. The third row is also valid in this case. Similarly, you can check the column wise. So for example, the first column here, you have 6, 5, 8, 1, 9, 7, 3, 4, 2. So as you can see, all the number from 1 to 9 is properly placed in the first column. Similarly, in the second column, third column, and so on. So that is checking all the rows, and also this one. And also that means you can create one row to check you can have one thread for each row. So yes, no, and for this one you can assign one thread to check all the rows, and then another thread, the second thread, to check all the column. So the first thread will check to make sure all 9 rows in which each row is a valid solution. Similarly, for the second thread, its function is to check whether each column is a valid solution to Sudoku. So that means you already have two independent thread, one to check the column and another one to check the row. And then you can also create another one. Sorry, this one 9 thread. 9 thread to check the subgrid. Subgrid 3 times 3 means this 3. Sorry, 624, 519, and 837. This is the first subgrid. The second subgrid is 539, 728, 614. The third subgrid is 187, 634, 295. So in total, you should have 1, 2, 3, 4, 5, 6, 7, 8, 9. Should have 9 subgrid. Of course, you can have the third thread to check all the subgrid, but for this problem, your task is to create 9 threads for each subgrade. That means for subgrade 1 you have 1 thread, subgrade 2 you have another thread, and the subgrade 3 you have another thread. That means to check for all these subgrade you have 9 threads. So in total you have one here for column, checking the column, all the column, the second thread to check all the rows, and 9 thread to check each 9 subgrids. That means total you have 11 grid, 2 plus 9. So in total you should have 11 thread to check whether the solution given here is a valid Sudoku solution. Okay, that is the problem, the main problem of this this project. Now we should start with the, because this is written in C. How to pass the value of row and column. So you can define this structure that contain 2 components, row and column. Of course, both are of the integer data type, and this is the name of the structure. And this is how you because you use a pthread library to declare the variable of to point to the structure. You can create it using this way. This is a pointer to structure. So you allocate a memory, a memory sufficient enough to accommodate this structure that contain the 2 integers here, and this is how you assign. So for example, you declare a data variable. So to set the value of row for this data, you can use this pointer symbol. So to set the row component of this data variable, you can use this statement. The second one is for assigning value to the second component and the column component. So over here you set the row is equal to 1 and the column is equal to 1. That means you are referring to row 1 and column 1. So that is how you assign or referring to any particular cell in the Sudoku here, Sudoku grid here. Now, based on our code, here just now should be in the Dropbox. Let me check in my Dropbox. This thread here. Okay, let us go through this code. What happened here? Okay, we use POSIX pthread in a POSIX operating system. So we use pthread library, this one, pthread library. So with this library, there are 3 main components. Actually, we have 3 main components. The thread ID you can declare it using pthread t. the attribute of the thread, you can use vthread attrt. So these two are the data type to declare or to create any new thread. You can use these two data type. One is to declare the ID of the thread, and the other one is to declare the attribute of that particular thread. And the third component is the what are the process to be executed by the thread. So you can declare a function. So the function should be in this format. It should be returning void pointer, and the parameter should also of a void pointer type. You have the option to use any valid name in C. For example, here this one thread, we call it runner. We call it runner. So you have these three components: the ID of the thread, the attribute of the thread, and the task to be executed by the thread or the thread function. It should be in this format. Now this is what we call the declaration of the function. The implementation of the function is in here. For example, here any data that you want to process by this thread, you can pass it through this parameter. So the parameter should be in void pointer data type. Okay, this is the three component. Okay, now before you can call the function, call this function. Once you declare the ID, the ID and the attribute, the variable to store the ID and the variable to store the attribute of that particular thread, you need to call the initialization function. So for vthread, you can use this function call, and then send the attribute and the address of the attribute. In person here means address of the variable attr. Once you initialize, only after that you can create a thread. So you need to specify the ID, the address of the ID of the thread, and the address of the attribute of the thread, and the function call for the thread, and this one is the data that you want to send. So yeah, in our case here, the data is sent through this argument in the prompt. So this is why you use RGB1. RGB1 means the data that you send through this one. So RGB1 referring to the second value in your when you write the program name, when you want to run the program in the command prompt. So this one is RGB1. RGB0 should refer to the program name itself. So that is the data. So if you specify 10, that means what you send here is 10. And then once this one should call when you invoke this function, what happen is this thread function will be called, the runner. This one, the runner will be called, and the data data to be passed to the runner is here. Yeah, this one is the second part of the function call. RGB1 will be sent to this parameter. Yeah. Okay, once this one finished, then you can join all the thread. So to join all the thread, you can use this one. So in this case, you only have one thread, so joining is you only need to join one thread here, yeah, which is the ID. So in the case of having more than one, then you have to call this function for depending on the number of thread you have. If you have 2 threads, that means you have to call this one twice. If you have 3 threads, then this function should be called 3 times, and so on. And this is the last one, and the last one should print out the output sum. Sum is referring to the global variable here, and you have to declare global, so that, remember, thread should share the same memory space with its parent, so all thread have the same access. So to make sure that all thread to have the same access, same memory access, then you have to declare as global. So that's why the function of this thread number 1 should have access to the global variable sum here. So any assignment function or to update the global variable will affect the value of the global variable here. So this one should be like this. So okay, this one is simply to process the data. So for example, let's say the RGB1 here contain number 10. So remember, when you send it this way, 10 actually 10 here is actually of data type string. It is not, sorry, array of character. It is not integer. This why you have to call this library Atoy. This one is will convert the value here from character to integer. So Atoy means alphabet to integer. So this one is from character into a numerical value. So you convert it and store it in the upper variable. And then okay, of course, initially the sum should be 0, and then you use the loop to do the summation from 1 to upper, and then the final value will be stored in the sum, and then the sum is actually, since it is a global variable, it should be accessible to this function runner and also in the main function here. Okay, of course, here once finished, you can return with this call with thread exit, and then return the value 0 to indicate that this if the statement reach this statement, that means and then returning 0, that means this runner function is executed successfully. So once you return, okay, you should get this, the final value that is just it's stored in sum, which should be printed out. So that is basically how you create a thread. You're gonna involve 3 component, the ID, the attribute, and the function itself. Okay. Now, in our case here, you have the pseudocode, right? So for the pseudocode, based on the guides in the textbook, you have to declare this one. And then if you want to refer to any column or any cell in the pseudocode, you can use this group of statement. So first you need to copy this one, put it somewhere. By convention, it should be put right after the macro include. Okay. Now this one should be the last. This one should be the last. Now the next part is to how to refer to this one. Now before that, you have to create this one. This one you can create, you can copy and paste this one. So you can create, you can store that the information as a text, in a text. How come this one? Copy. Okay. So you have to manually put the space between of the number. Yeah. And save this file as let's say we call it sudo.txt. So any name should be okay. So let's call it sudo.txt. Now since this pseudocode data is stored in a text file, then you need to create lines of code to read through all the data. You have to declare you have to use the file descriptor, and you use the function called fopen, and then read the text file, specify the name, and the mode is read R, which means R stands for read only. And then to store the data, you have to declare the array. Declare the array integer pseudocode. You can call it pseudocode, and the size should be it is 2D, right? So 999 pseudocode 99. And the function call, the thread, you must have one thread to check the row. Then you can call it check row and send the data param. you have one check column, and then check the subgrid. Check grid 1. This is subgrid 1. How many grid? How many subgrid do we have? 9, right? So you have to declare one by one. You should have 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. You have the option to delete all this. This is one option. Another option is to simply to create one thread function to check all grid simply by referring to the index here. So if the index referring to the, for example, you can use 0, 0 means the first one, 0, 3 referring to the second one, and 0, 6 referring to the third subgrid. So depends on your implementation. So of course I prefer this one, but this one also acceptable, but it is not elegant, since if you have a very big pseudocode, then you have to declare more lines of this function declaration. So this solution is much more elegant, but both are still acceptable for this assignment. Through the content of the text file, so you can use you can declare a temporary variable. You can call it number, and then to read through the content of the file, you can use scanf, and then number here. You have to specify, it should be, because the data is in integer, then you can specify D here, and then you can use, it should be fscanf, referring to you are reading from a file. So specifying the file handle and the address of the variable to store the data. So because but this line will only read the first data, the first integer 6 here. So to go through all data here, 81 integer, so you can use loop. So you can say integer from, okay, you can you have row from 0 to 9, then you say row plus plus, this is 2D, so that means column. The next, you can use nested loop to read through the and it should be like this. Yeah. So once the loop is finished, you can close the file. You can use this function, close. Okay. So okay, now yeah, you have to put it into the sudoku variable, right? So that means sudoku row column, row here and the column here, column equal to number. Now let's check the row. Let's check the row one by one. To make it easy, you can use numbering here. So this one, let's say you say this one is check the ID for checking the row, for example. Attribute checking the row. So you can comment this one. And then this one, rename it for checking the row, and also this one, thread for checking the row, and this one is checking the row as well. Now over here, it should be no longer, it's not runner anymore. It should be check row, right? So this one should be check row, and the argument here is this data. So you can copy the this one. So you can declare that somewhere here should be okay. Okay. Here, 0 0 referring to this one is not required. This one is only required if you are checking the subgrid. Never mind that one. But yeah, you can still specify the one. Not required. We can specify null here, because this one because the data is is declared as global here, so you can simply the check row function simply can refer directly to sudoku, and then you don't need to specify any pointer here, because this thread is checking all the rows. Okay, then okay, this one you can ignore this one, but you can use this template. You call it check runner, right? Check runner. Sorry, check runner, check row. Now you have to check all the row to make sure it is a valid solution. So you can start from row number 0 until row 9, right? And then what is the algorithm to check all number exists in the any particular row? For example, all this number exists in the first row from 1 to 9. Similarly for the second row. I found out one of the simplest solution is you should notice that the sum of this number, all these 9 number is 45, right? Here the sum is 45, so I can use that to validate the each row. If the sum is 45, then I know that row is valid. So what you can do, you can use sum 0, sum 1 or sum 0 equal to 0, and then you can say sum 0 equal to Sudoku from 0 to, sorry, and this one is column. This one should be column. Then you can have something like this. So this one to check the first row. So you can have another loop here, but this is for the second row, right? Second row here. This one row number 1, and so on. Or you can declare it here. You can say integer sum of row 0, sum of row 1, and so on. Of course, the other option is to declare an array, right? So again, if we declare an array, so we can simply use something like this. So sum row 0 equal to something like this. So you don't have to declare. So you don't have to declare all this. So you can use row number 1, right? So anyway, you can have your own implementation. So and then you can write all the checking. So this is the first row, second row, and so on. Of course, you can use nested loop to check all the rows instead of having this 9 block of rows. So you can use nested loop to check the solution for each row. So if the sum is equal to 45, then you know the row is valid. Now that means you have TID check row here. You call it here check row. And you have the solution. Then you can check. Now the second one. Second one is to check the column, right? Similarly, you have to create another thread here. You have to create for checking the column, and then you have to initialize, and then lastly to create the thread column. Again, this one you don't have to specify any data, so you can safely send a null pointer. Now the implementation of the check column should be the opposite of this one. So opposite of this one, column. Yes, you need to have another global variable here. This is just an example. You can have your own way of declaring this one, because you should notice here you have two array. You can actually declare one single 2D array here instead of declaring two array here. But again, it is up to you. So this one should I call it column, but this one should be column. Now this one row here. And this time should be the other way around. Row here, and this one should be this one. Nice. Okay. For now, the checking row will check the first two rows. The second thread will check the first two columns. And then over here I can join. You have to join the two thread. You have, because you already create the two thread. Once they are finished, you can join it here. This is to terminate the thread, and then you can check the validation here. Okay, so you can say, just to make sure, the output of the first row, row one. What is that? Sum of row 0, right? This is referring to the row number 1, and then you have the row number 2, which is 1, and then you have the column, checking the column number 1 and column number 2, and then you should have column. Okay, so if the all these four, the output is 45, that means the row, first row and the second row is valid. It's a valid solution for that particular row. Similarly for the column. Let's compile this one. see what happened. It is thread, right? GCC thread minus O thread. What is that? Row undeclared. Line 110. 110. Yeah. Yeah, this one should be row. I forgot to change this one. Yeah. Now let's see. The row 1 is 0. What happened? Okay, I got it wrongly here. So this one should be 9. Let's compile this one again. Yes. If the sum is 45, then you know the solution is valid for that first row and the second row is valid. But the assumption is the value should be all positive from 1 to 9. If you allow negative number, then this technique is not sufficient enough. Now let's try change the first row. Let's say this one, change it to let's try change this one to, let's say, 7, 8 for example, and then see what happens. 7, 8. No different because you changed the last one. Sorry. Let's change this one. This one. Let's say 1, 2 here. Let's see what happens. Okay. One of the row is not valid. The second row. Second row is not valid. Sorry. Is it the row number 2? 46, right? The first and the second row is not valid. But the column is still okay. The first column and the second column is okay. This one, because you put 2, 1 and 1, 2 will result in the same sum for the column, but it is no longer valid for the row. Let's try change. How about this one? 2 and 6 here. Okay, the first two row is still valid, but the column is no longer valid. It should be 40, 45. The two column is no longer valid. Okay. I have demonstrated to you how to validate the first row and the second row and the first column and the second column. So okay, I'll leave it to you to continue with checking all the row, checking all the column, and also the most important one, the subgrid. Because this one, you have to check all the nine subgrid. So okay, that's all. Good luck. All right. Yeah, the output should be something like this. If your program run successfully, so the output of your program should be something like this. This one, for example, checking all the column from column 0 here referring to the first column up to column 8. The output should be all 45. The row also, the output should be all 45, and the output for all the subgrid, you have 9 subgrid. 06 referring to subgrid number 1, 06 referring to second subgrid, 00 referring to subgrid 1, 03 second, 06 is the third subgrid, and then the fourth one is 30, the fifth 33, 36 is the sixth subgrid, the seventh one 60, subgrid number 8 is 63, and the last one is 63. So all the outputs will be 55. And then you indicate if it is equal to 45, then column 1 is the flag should be 1. You have another variable to total out the number of flag. So if the number of flag is, because you should not notice here, we have 27 checking here, right? You have 9 checking for the column, 9 checking for the row, and 9 subgrid. So that means total you have 27. So if your flag equal to 27, that means all 27 checking is true. That means you can use an integer to indicate. So if the flag is equal to 27, that means all checking is valid. If it is less, then you know the one of the solution is not valid. So if it is equal to 27, that means the Sudoku is valid. Let's say, for example, you change one of the, let's try change it to 47, for example. So when you run this one, it is no longer valid. So I change it back to this one, the output should be valid. Now, so you should notice when you run, every time you run, you will get different order. For example, the first run here, you get this order. Sometimes you get the order is different. Sometimes the first 9 column, then followed by the subgrid, and then the row, and then another subgrid. Run it for the third time, you'll get different order. Now this is how thread works. Threads will be executed randomly, but most likely the first maybe the first few thread will be in good order, but after that we'll get random order of, for example, this one. It will execute the first 9, and then the subgrid, and then all the 9 rows, and then followed by the subgrid. You run it for another run, you will get different order. So this is normal. This is how the thread is invoked by the operating system. Your output could be slightly different, but this is the best solution if you can get this output. Okay, good luck again.